All right, we're trying a new setup here. Hopefully I minimized the glare enough. We are on assignment 4. Assignment 4 is all about empirical formulas. Now, as some of the other videos showed you, empirical formula is the simplest whole number ratio, whereas the molecular formula is how things actually appear on Earth. So, number 4, for instance, tells us that the way this substance looks in the real world is 2 carbons, 6 hydrogens, and 2 oxygens all bonded together. This is how it actually appears, which makes this its molecular formula. Now, if we want to get this to its empirical formula, what we need is the simplest whole number ratio. So, if we have 2 and 6 and 2, we know that math, we can use what's called the GCF, or the greatest common factor. And this is not as simple as it could be. If we divided all of these by 2, that would give us an empirical formula of CH3O. We can put these ones here if we want to, but they're not exactly necessary, kind of like x and 1x in math. But that would be the simplest whole number ratio. That would be the empirical formula. Now, number 6 gets into a much more complex question, but it is giving us some percent composition. You can see that assignment 3 had to come before this one because we just figured out what this really means. But if we take this mystery substance, what it's telling us is that 47% of it is always potassium by mass. 14.5% of it's carbon and 38.5% of it is oxygen. No matter if I have a spoonful or 100 pounds, it is always going to be in this exact same proportion. So what we'll do a lot of times is, for math's sake, we'll say, well, let's say we have a 100-gram sample. The reason why is because the math is easy then. If I have a 100-gram sample and 47% of it's potassium, that means I have 47 grams of potassium. Likewise, if I have that same 100-gram sample and 14.5% of it's carbon, I know that I have 14.5 grams of carbon. And last but not least, we could subtract, but it's the same proportion, and you can see now why we use 100 grams. If we have a 100-gram sample and 38.5% of it's oxygen, what that means is we have 30.5 grams of oxygen. Now that right there is a huge step, but we know that in chemistry we can't just compare grams of these different things with each other because oxygen weighs different than carbon does. So this right here though is important, and usually when I teach empirical formulas, I teach 3 letters. The first one is G. G stands for get it to grams. The next letter I usually use is M. We know that in chemistry, if we're going to compare numbers of particles, we need to get to moles. So hopefully you guys are getting good at this, but now if I want to get from grams of potassium to moles of potassium, I need to divide it by its molar mass. So I know I'm going fast here, but you can look this up as we go. The molar mass of potassium is 39.10, which would give me 1.2 moles of K. Now, I got to do the same thing here. Now, a lot of kids are going to want to come and take this number and pop it right here, but that doesn't make any sense. If I want to get from grams of carbon and I want to get to moles of carbon, I have to divide by the molar mass of carbon, which if we go look on our periodic table is 12.01. What that comes out to be is 1.20 moles of carbon. Now this should start to make a lot of sense, because if I look at these two numbers, it does make a lot of sense that they're the same, because a lot of times we're going to have the same number of moles in a compound. Last but not least, I need to get from grams to moles for my oxygen. So in order to get from grams of oxygen and get to moles of oxygen, I have to divide by the molar mass of oxygen, and all of a sudden here something weird happens. We get a number that's a little bit different. Now on this one it's pretty easy for us to see. I know mine isn't great, I'm sorry. But it's easy for us to see, we have a ratio here. 1.2 and 2.4 are related. So the third letter of the way that I teach this is GM, and then the last letter is S. S stands for simplify. We know that in chemistry, I can't take these things and go, well, hey, K is 1.2, C is 1.2, and O is 2.4. I can't leave them like that because that's not an empirical formula. That's not a whole number. So the way that we simplify is to divide by x. We're going to divide them all by the same thing. And what x will be is the smallest number. So in this case, our x is 1.2 because that's the smallest number of moles. And now if I take 1.2 divided by 1.2, that gives me 1 potassium. If I take 1.2 divided by 1.2, that gives me 1 carbon. 2.4 divided by 1.2 will give me 2. You'll know that you'll do this right because it should always come out to whole numbers. So we can't leave it with that. We got to go write our nice new empirical formula. I know it's kind of messy on my little board, but we found that there was 1 potassium for every 1 carbon, and then we have 2 oxygens there. So what we probably end up going and writing is KCO2, which would be potassium carbonate. Very, very nice. I know it got kind of messy here, but get to grams, get to moles, and then simplify, and that should get you to where you get a nice whole number, which is exactly what we want to see when we're looking at those empirical formulas.